Okay, how do we take the derivative of an exponential here? Let's assume that we are given y is equals to e raised to the power of u, and we are told to find the differential form of y. Using the formula y, derivative of y is equals to, focus on the power to which the Euler's constant is raised to. The Euler's constant is raised to the power of u. Then differentiate the power. So I'm going to have the derivative become like this. Differential of the power to which the Euler's constant is raised to multiplied by the function itself. What is the function? The function is y is equals to e raised to the power of u. So in that case, I'm going to have y, differential form of y is equals to u multiplied by in u. That is u differential multiplied by in u. Now let us proceed. Let's assume that we are given a function f of x is equals to 2e raised to the power of 2x. Using the same approach that we have here, we can say that since the power of Euler's constant is 2x, so I'm going to have u is equals to 2x. In my formula, I need the differential form of u. So I'm going to take the first derivative of u. The first derivative of u using the power rule is 2. So I'm going to have 2 here. After getting the derivative of u, I can proceed to use this formula. The differential form of this function f of x is equals to the differential form of u, which is ui, multiplied by the function itself, which is fx. Ui, that is the differential form of u, the first derivative of u multiplied by the function. And don't forget that the first derivative of u is 2. So I'm going to have the first derivative of fx is equals to 2 multiplied by f of x is 2 in 2x. So 2 multiplied by 2 in 2x. So in that case, I'm going to have f of x, first derivative of x is equals to 2 multiplied by 2. That is 4. So I'm going to have 4 in 2x. We have question number 1. F of x is equals to in x. Don't forget the procedure. The first thing is to focus on the power to which the Euler's constant is raised to. In that case, I'm going to be having u is equals to the power to which the Euler's constant is raised to. So I'm going to have u is equals to x. So from the formula, I need the derivative of u. So I'm going to take the derivative of u. U derivative is equals to 1. Don't forget the formula. The formula goes thus: the derivative of fx, the first derivative of fx is equals to u derivative multiplied by the function itself, which is fx. So in that case, we are going to have the first derivative of fx is equals to the derivative of u is 1. So I'm going to have 1 multiplied by, what is the function? The function is what? In x. Fx is in x. So in that case, I'm going to have in x. So the first derivative of x is equals to in x. So now let us proceed to the next question. We have y is equals to in 2x. The first thing is to set u equals to the power to which the Euler's constant is raised to. So I'm going to have u is equals to 2x. And from the formula, I know that I need the derivative of u. I need the first derivative of u. So I'm going to have the first derivative of u is equals to 2 using the power rule. Probably you don't know how to solve differential equation using the power rule. You don't know how to differentiate using the power rule. You can proceed back to the channel and watch how I use the power rule to differentiate a function. So now let us proceed. We have u equals to 2x. The derivative of u is equals to 2. Now don't forget our formula. If I want to find the derivative of y, the derivative of y is equals to the derivative of u, which is the power derivative of the power to which the exponential function is raised to, multiplied by the function itself, which is y. So I have gotten the first derivative of u, that is 2, and the function is what? Y. Y is equals to e raised to the power of 2x. In that case, I can substitute both derivative of u and y. The derivative is 2 multiplied by, what is y? Y is equals to in 2x. So I'm going to have in 2x in this place in 2x. So the derivative of y is equals to 2e 2x. So that is the derivative of y is equals to e raised to the power of 2x. So in that case, I'm going to have the derivative is equals to 2 e raised to the power of 2x. So let us proceed to question number 3. Okay, we have y is equals to e raised to the power of x squared plus 1. Don't forget our approach. The first thing is to set u as the power to which the exponential function is raised to. So in that case, I'm going to have u is equals to x squared plus 1. The derivative of u derivative is equals to, using the power rule to differentiate this x squared, I'm going to have 2x, and if you differentiate a constant will give 0. So in that case, the derivative of u is equals to 2x. Now the next thing is to recall that our formula is the derivative of y is equals to the derivative of the power, which is the u, multiplied by the y itself, which is the function. So in that case, the derivative of y is equals to, what is u? Derivative of u is 2x. So I'm going to have 2x multiplied by y. Y is equals to e raised to the power of s squared plus 1. In that case, I'm going to have e raised to the power of s squared plus 1. So the derivative of y is equals to 2x 2x in s squared plus 1. So that is the derivative of y is equals to e raised to the power of s squared plus 1. Now let us proceed to the next question, which is the fourth question. Y is equals to 5e raised to the power of 4s squared. What's the answer? You can drop your answer inside the comment box. I'm going to assess it. So now let's try this. Don't forget that the first thing is to set u is equals to the power to which the exponential function is raised to. In that case, I'm going to have u is equals to 4x raised to the power of 2. So we are going to take the derivative of u with respect to the independent variable, which is what, x. So I'm going to have u is equals to, the derivative of u is equals to this power multiply the coefficient. I'm going to have 8x, the power reduced by 1, that is 2 minus 1, x raised to the power of 1 is 1. So in that case, I'm going to have the derivative of u is equals to 8x. Then after getting the derivative of u, don't forget that the differential equation of y, the derivative of y is given by derivative of the power to which the exponential function is raised to, u multiply by the function itself, which is y. In that case, don't forget that our y is equals to 5e raised to the power of 4s squared. In that case, I'm going to have the derivative of y is equals to the derivative of u is 8x multiplied by y, which is 5e raised to the power of 4x squared. 8x multiplied by 5, that is 40x. In that case, I'm having y derivative is equals to 40x multiplied by e raised to the power of 4x squared. Therefore, the derivative of y is equals to 5e raised to the power of 4x squared is 40x e raised to the power of 4x squared. Now, the fifth question we have, y is equals to e raised to the power of sine x. Don't forget, using the same approach, we have to set u equals to the power to which the exponential e is raised to. In that case, I'm going to have u is equals to sine x. And in differential calculus, if you differentiate sine x, if you differentiate sine x, sine x will give cos x. And if you differentiate cos x is equals to minus sine x. In my next video, I'm going to show you how to prove this. But add this at the back of your mind. If you differentiate sine x, you are going to get cos x. If you differentiate cos x, you are going to get minus sine x. So in that case, let's proceed back. Let's come back to our question. We have y is equals to e raised to the power of sine x. The first step is to set u as the power to which the e is raised to, which is Euler's constant. So I'm going to have u equals to sine x. Then take the derivative of u. The derivative of u is, don't forget, in differential calculus, when you differentiate sine x, you are going to get cos x. So the differential of sine x is equals to cos x. So don't in that case, I can proceed and said derivative of y is equals to derivative of u multiplied by the function y itself. So the derivative of y is equals to derivative of u is cos x. I have cos x here, cos x, cos x multiplied by, don't forget that the function y is equals to e raised to the power of sine x. So I'm going to have e raised to the power of sine x here. So the derivative of y is equals to cos x e raised to the power of sine x. So that is how to find the derivative of e raised to the power of sine x. Now let us proceed to the sixth question. We have y is equals to e raised to the power of cos x. The first thing to do is to set u to the power to which the Euler's constant is raised to. Follow the same approach, get your answer and drop the answers in the comment box. I'm going to check it and reply. Thank you very much for watching the video. Probably you have not subscribed to our channel, you can click on the subscribe button. If you like the video, react by liking.